students, welcome back to my channel where I try to make mathematics a bit more fun. And I think I should get back to teaching English because first of all nobody watches my videos anyway, and secondly making videos in English probably would help it a bit to get to a few. I don't know if this thinking is right or not, but I believe that most Indian youth can at least understand English. Okay, idea series it is. This is I think the 8th video of the series. Just wait a second. So today we will be focusing on solving of problems. Okay, so let's start with basics. The first question says asks this value, which is 2 times 10 inverse of half. The options are A 10 inverse of 3/4, B sine inverse of 4/5, the cos inverse of 3/5, and D 10 inverse of 4/3. Okay, now we will ask to evaluate this. So first of all, I think I have told you guys in the video that how tan and other how all the trigonometric entities are related. I can say that inside of this tan inverse function I have this value 1/2, and it would be very difficult to find this value for tan. But I know that like trying to find out this value for sine and cos is going to be very easy because I know that sine of pi by 6 is half and cos of pi over 3 is. So why not try changing this into sine or cos? This would be the same as 2 times sine inverse of this is length and this is base. So sine inverse is gonna be length over hypotenuse, that is 1 square plus 2 square, that is gonna be 1 plus 4, that is 5. Okay. Now sine inverse of 1 by root 5, I still don't do that. So I can maybe try changing this into cos. How do you think this is going to look in cos? In the cos, this should become cos inverse of 2 over root 5. So how do I solve this one? First of all, I would recommend you to try this on your own. Only then I would recommend you watching this or continuing this video further. Assuming that you have tried this on your own and have failed to solve this, I'm gonna proceed. So the first thing that might come across into my mind is that try to convert this into any kind of any other trigonometric function. Maybe take that first, because first of all I don't know tan of what equals how. So first of all, let's try converting this into any other trigonometric function. Inverse trigonometric function, that is. For sine, it would be sine inverse of 1 over 2 5. For cos, it would be cos inverse of 2 by root 5. But the problem with these two approach is also the same. Is that I don't know what for which angle value sine of that angle value is 1 over root 5. And I also don't know cos of what is 2 over root 5. So this approach is not gonna work here. I have to think of something different. So one thing I can notice that is that we have a 2 multiplied in front of this inverse trigonometric function. So I can rewrite this as tan inverse of 1 over 2 plus tan inverse of 1 over 2. I can rewrite this at like this. And in the previous video, I know that video was in English, Hindi, but I would assume that you guys watching this video are proficient in both languages. So I had taught you guys a formula regarding this sum of two tan inverse functions. It would give us first of all, let me find out what is actually. First of all, let's say that that tan inverse. Actually, it's not necessary. I have told you guys what it actually becomes. It becomes tan inverse of 1 over half plus 1 over half over 1 minus 1 over half times 1 over half. I had actually proved this for all the previous videos. So this will become 1 on top, and then the bottom we would have 1 minus 1/4. This will be 1 over 3/4, which will be the same as 4 over 3, and we are going to be having a tan inverse in front. Tan inverse in front. Okay, so the final answer would be option D. Answer would be option D. Okay, now I would approach a bit more difficult question. Let's try solving this one. It says cos inverse of 1 over root 5 plus cos inverse of 2 over root 5. You have been asked about that, and the options are the options are 0, 1, pi, and pi over 2. 0, 1, pi, and pi. Okay. Actually, this one is actually a bit more simpler. I would recommend you as trying this one as well before watching this video further. Next time I will ask to evaluate the sum of two cos inverse functions. Assuming you have tried solving this on your own, proceeding, you know what the formula of this is as well. This is cos inverse of 1 over root 5 times 2 over root 5 minus root over 1 minus 1 by 5 over 5 times root over 1 minus 2 over 5. If you guys are wondering where this came from, in the previous video I had already proven that cos inverse of x plus cos inverse of y is the same as xy minus root over 1 minus x square times root over 1 minus y square. Okay, so this would become 2 over 5 minus this is 4 over 5. So I can just actually do it. This is root over 4 over 5 times root over 3 over 5. So I can rewrite this as 2 over root 5 and let's just let this one stay like this. And upon multiplying, this becomes 2 over 5 minus 2 3 2 3 over 5. Now actually I made a mistake here. When I'm a human too, so obviously I am expected to make mistakes as well. The formula was 1 minus y square here, so it would be 1 minus 4 over 5, not 2 over 5, and this would become root of 1 over 5. That just becomes 1 over root 5, and this would become just 2 over 5. So instead of the cos inverse function, I have 2 over 5 minus 2 over 5, that becomes 0, and cos inverse of 0 instead of the range of the primary values is pi over 2 radians. Okay, so this terms 2, this is 2, the answer is option D. Okay, I'm gonna solve one more question for this video, and this chapter is not that hard anyway. Just trying to help you comprehend how to do. Basically, I'm trying to make you guys think on your own about like where to apply these identities and how to apply them. All this. This time, let me try a bit hard one. Like, this one. This one says tan inverse of root over 1 plus cos x plus root over 1 minus cos x by root over 1 plus cos x minus root over 1 minus cos x. We have been asked to evaluate this, and the options are x over 2 pi over 4 plus x over 2 pi over 4 minus x over 2 pi over 4 plus x. Okay, so let's try solving this one. So in order to solve this one, we would have to be aware of an important trigonometric identity of 11th standard, which says that 1 plus cos theta equals to cos square theta. 1 plus cos theta is 2 cos square theta, and 1 minus sin theta equals to sin square theta. Okay, and if you are wondering where the identity came from, I would either recommend you watching. I know I don't have any talking about 11 as of now. You can check now in your textbooks on. You know what? Wait till the end of this video. I'll prove it. Before doing that, just solve this one. Tan inverse of so this quantity is root over 1 plus cos x. So this can be written as root of 2 cos square x plus root of 2 sin square x over root of 2 cos square x minus root of 2 sin square x. Okay, now this can be rewritten as root 2 sin x root 2 cos x plus root 2 sin x in the denominator as well. We would have root 2 cos x minus root 2 sin x. Okay, now what we can do is we can divide both the numerator and the denominator by root 2 cos x. Root 2 cos x root 2 cos x over here root 2 cos x root 2 cos x. Now why did I do that? Because I can notice a pattern here. If that if somehow I can get 1 plus basically what I want to do here is I want to get a pattern inside of this tan inverse function, which is basically like tan inverse of a plus tan inverse of b, tan a tan b, something like that. Tan a plus tan b over 1 minus tan a tan b, something like that. And tan if like I can see that 3 out of 4 fronts have pi over 4 instead of them. And what is tan pi over 4? Tan pi over 4 is 4. So somehow it's most likely out of these three options. So somehow I would want to get 1 instead of this, which is 10 pi over 4. So how would I do that? I would do that by dividing both the numerator and the denominator by 2. And this would get me, this would do is, on the top I would have these two root 2 cosines which cancel out each other, root 2 and root 2 would cancel out each other, and this will become 10. And the denominator as well, root 2 cos x and root 2 cos x would cancel out each other, root 2 would cancel out each other, and this will become 10x. So this whole thing would become 1 plus tan x over 1 minus tan x. Now I can rewrite this as tan pi over 4 plus tan x over over 1 minus 1 times tan x, or I can get this 1 as tan pi over 4. Okay, why did I do that? Because I want this to look like one of the formulas, one of the identities that I've learned regarding this inverse trigonometric equations, because that would make things a lot easier for us. Okay, now how does this look like to you? This kind of looks like, I mean, this not kind of, it is tan of pi plus pi over 4 plus x. So I can rewrite this as tan of pi plus 4 plus x. Okay, now tan inverse and tan both would cancel out each other, and that would happen because this value is inside of the primary range. I mean, I know that we are not aware of what this value is, what x is here, but it's most likely going to be inside of that range, because otherwise none of the options would make sense here. So this would become pi over 4 plus x, which is again option D. This is not shifted. I mean, I have not made it such a way that all the answers should become option D. Sorry about that. For whatever reason, all the problems that I have solved today have option D as the answers. Okay. Now coming to this proof, which says 1 plus cos theta equals to cos square theta, and 1 plus sin theta, sorry, 1 cos square 1, no, it was actually 1 minus cos theta, I think, I remember that. Sorry for that. Let me check the question again. Is equals 1 minus cos theta. Now let me try proving this one, this two identities. First let's talk about this one. I can rewrite cos theta as this can be rewritten as cos of theta over 2 plus theta over 2. Okay. This will, we do know the identity of this, so this becomes cos theta over 2 times cos theta over 2 minus sine theta over 2 times sine theta over 2. Okay, the left side would become just cos theta. The right side would become cos square theta by 2 minus sine square theta by 2. Actually, this was alternative was 2 cos square theta over 2. Theta over 2. The option was actually option B. Sorry for that. I made a first mistake here. Pardon me. Extremely sorry about that. This would be the answer because the identity was actually this. Sorry for that. Now what I can do is this will become just cos theta. Now I can add 1 on both sides. 1 plus cos theta would be 1 plus cos square theta by 2 minus 1 minus sin square theta by 2. Now this can be rewritten as sin square theta by 2 plus cos square theta by 2. Okay, and now sin square theta must be cancel each other. This would just become 2 cos square theta by 2. Okay. Now the same way, if I changing the signs of both sides, minus of cos theta would become minus cos square theta plus sin square minus cos square theta over 2 plus sin square theta over 2. Now if I add 1 on both sides, 1 minus cos theta. The right side I would have 1 minus cos square theta plus sin cos square theta over 2 plus sin square theta over 2. Again I can rewrite this 1 as sin square theta over 2 plus cos square theta over 2. Okay. Now I can cancel out these 2 cos square theta over 2 plus and minus. This will become 2 sin square theta over 2. And these were your 2 2's. Actually, sorry about this question mistake here. I acknowledge my mistake here. The answer would be actually option B. Pi by 4 over x over pi by 4 plus x over 2. Okay. So this was it for this video. If you guys think that you have doubts regarding anything I have told you guys in today's video, then do let me know about it in the comment section. I have tried to solve that. Okay. Until then, keep learning.